Hi students, how are you? Now we have done that Sn2 reactions. Theoretically, we have done the Sn2 reactions. So in the previous video, I told you we will discuss the next in the next lecture few questions which will enhance your knowledge, enhance your concept uh, regarding Sn2 reactions. Okay, so let's discuss the some questions. And you think that pause the video and then you think that which answer is correct. Now I'm discussing with you these 7 to 9 questions which is very important, and I picked the questions from the different questions so that your concept should be clear. Okay, so let's start that Sn2 reaction based questions. Okay, see here students, one I have taken the one question which of the following alkali halide will be readily give Sn2 reactions. Now see that here is the bromine attached with the first carbon, that is the 1 degree carbon. Here is 2 degree carbon. Here is 3 degree carbons. Okay, but in the Sn2 reaction, what I taught you, the beta position is complex positions. When the beta position is complex positions, in that case, the reactions will go very slowly as compared to 3 degree. Obviously, as compared to 3D, that will go, but very negligible. Correct? So if I ask you, write the order of the Sn2 reactions of this compound. So see what happened. That will go fastest. Am I right or not? That will move in the fastest. So 3 is the fastest. Okay. Here I write 3 will be the fastest, and then after 3, which will go second, and second then first, and then fourth. I hope you understood. Correct? Why? Because here is a 2 degree. That's okay. Here is also 2 degree, but there is a, again, beta position is complex. Correct? So therefore, as compared to third and second, third will go faster than second. And why when we compare with those? Because both are slow, even it is a negligible, but it will go very 0.05%. But even though we can say that 0 point means here is impossible, but here will be negligible but not a 0. So therefore we can say that third, second, first and fourth. Correct? Okay. Next we go to the decreasing order of rate of Sn2 reactions. Students, what I taught you, whenever Sn2 reaction is there, you check that electron withdrawing group in the chain or not. If electron withdrawing group, definitely that will go faster in the Sn2 reactions. So here and the Sn2 reaction, I taught you the excellent which will move in the Sn2 reactions. So see that carbonyl compound, the beta carbonyl is the excellent, that will go faster in the Sn2 reactions. So obviously that will move with the faster in the Sn2 reaction. Then here is methyl halides, and then ethyl halides, and then these compounds. Clear? Because excellent and then the good, and here is that okay, but that will go to the average, and here is that very poor, because again there is a beta position, not too much hindered like that, but okay, this is the order. The fastest is the beta carbonyl, then the methyl halide, then this, and here is okay. Now next is, what will be the rate of Sn2 will be negligible in? Rate of Sn2 will be negligible. Student C. Again I am telling you that Sn2 reaction we have done in the last points, that what the cyclo compound also involved in the Sn2 reactions. So cyclopentane and cyclohexane, which will go faster, cyclopentane. But here is a cyclohexane that will go reaction in Sn2 reactions. And here is the allyl. Student, I have written this compound as a, here is allyl. Obviously allyl will go in the Sn2 reactions. And here is that compound, what? This is the, here is this compound, so that will also go. But here is the bridgehead atoms, student. The bridgehead atoms is all just treated as a 3 degree. So here is the 3 degree. So it will be move into the negligible. Correct? Okay. Next we go to the, which of the following is the most reactive towards Sn2 reactions? Check that. Is the electron withdrawing group or is the carbonyl compounds? Here I have checked that this compound contains the electron withdrawing group, C double bond O group, carbonyl compound, which is the fastest in the Sn2 reactions. So first will go, and then the PHCH2H, benzyl chloride, and then the allyl, and then these compounds. Clear? I taught you benzyl and allyl also go in the Sn2 reaction, but condition is should be a strong nucleophile. If your nucleophile is weak, that will move into the Sn1 reaction. Okay, now see here the slowest rate of reactivity of ammonia with the following compound. Students, I taught you in the basicity and nucleophilicity, that is very very important. I suggest you any students who directly come in the questions, before that you complete the both the nucleophilicity, basicity and living group. So see here the least reactive. Student, ammonia is the what? Ammonia is that strong base. So that will form their NH2 negative, which is conjugate base, and so you know conjugate base, it means what? Will not favor Sn2 better. That will move into the different reactions. That will under the different logic I will teach you. But here is the what? So NH3 that will move into the NH2 negative. So the point is which will go slowest? Sn2 reactions. So here check that which will go slowest, or which will go slowest, that Sn2 reactions, or you can say that the Sn2 reaction, because ammonia is the what? The base. Ammonia is not a good nucleophile, correct? So it means what? So good base means what? Not a nucleophile, that will be a base, correct? Huh? So now you check that. So which will go fastest in the Sn2 reactions? Okay, so third will go, here is a no hindrance, correct? After third, here is second is there, correct? And then 3 degree and then the 1 degree. Clear? Okay, now see here, the question is that sixth, we have a compound NaI acetone. I have taken the 1 mole strength. Now I have taken the 1 mole in the presence of acetone. What happened? Students, first you search which is the better living group. Which is the better living group, students? Better living group is what? See which will be better living group. Student, Br NaI, obviously bromine, iodine can replace the bromine because bromine is a better living group. Okay, so iodine will replace to the bromine, but what would be the compound, actual compound? Student, that is the inversions. So bromine, iodine will not attach at the same positions. No, first iodine will attach and then the inversion will happen. So inversion, here is the iodine. So here is the iodine, means what happened? Here is the no, here is no inversion because iodine attached at the same positions, correct? And here is that here is the iodine attached on the after the inversions, correct? And here is the bromine. So here is bromine and here is the bromine. It means the fluorine is replaced. So that's not a possible because bromine is better living group. So iodine can replace the bromine rather than the fluorine. Okay, so that's two option is impossible. So go A and B. Obviously B option is correct because here is inversion happen. Understood? So that is the B is correct answer. Now next is Sn2 reactions will more rapidly. Students, see here, here is 3 degree, here is a 1 degree halides. So obviously 1 degree halide will move faster than the 3 degree. Okay, next is that we have the same questions, OH minus. So check that Br is better living group. So OH will replace, but how replacement will happen? OH will not attach at the same positions. OH attach and thus just inversion will happen. So here is no inversion happen, but in option B you can check there is inversion happen. So obviously B is correct answer, not A. Okay. Okay, see here, NaI acetone again. So NaI acetone I have taken. So now first to check that which positions will be iodine will attach. Obviously, where is the living group? Iodine will attach that positions. So iodine attach the where the living group is there. So there is no living group, there is no living group. So iodine will attach here. But what happened? Again, inversion will happen. See, is there inversion? No, because iodine attach the same positions. Here is the inversion? No, here is the no. So only these positions inversion is happen. Rest position will remain same, but this position is inversion happen. So here is a Sn2 reaction faster. Now my questions to you, what about these reactions? What about this reaction, students? Tell me. Here is the CH3. Okay, obviously NaN3 means N will attach these positions. So what will happen? When N will attach, the inversion will happen. So N3, Here is the H will happen and rest position is remains same. Correct? HCl, CH3. So that is the answer of these questions, means Sn2 reactions. So whenever attached, the inversions will happen. So but how will inversion will happen in the questions? This is the way. And in the MCQ, either the NEET or JEE, these questions already came. So just do one time practice and that's enough. So next video lecture we have for the mechanism of NCRT, especially NCRT reactions, which is based on the Sn2. With the detailed, we will do that. So stay, and if you feel that you understood the questions perfectly, you share it and like it and subscribe. Don't forget to subscribe.